zipmap function. Zipmap builds a map by pairing one list of string keys with one list of values in the same position. If index 0 in the keys list is dev, and index 0 in the values list 10.1.0, Terraform produces a pairing dev equals 10.0.1.0. This matters because the function does not infer relationships. It trusts list order. The outcome is a map you can address by name instead of by numeric index. The first constraint is length. Both lists must contain the same number of elements. The second constraint is key type. The keys list must be strings. Values can be any type Terraform accepts in the list. The outcome is predictable structure only when both lists are aligned before zipmap runs. If either rule breaks, Terraform stops with an error instead of guessing. Zipmap is useful when data starts as two separate lists and must become one addressable object. That happens when teams store names in one variable and values in another, or when upstream data returns parallel arrays. The mechanism is conversion from position-based access to key-based access. The outcome is cleaner downstream code because local.metadata service is easier to reason about than local.metadata index 1. A common use case is converting parallel lists into a map that for each can consume. For each wants stable keys because resource instances are tracked by key, not by list position. Zipmap gives Terraform those keys. The outcome is safer scaling because each instance gets a meaningful identifier such as app name or log level instead of an unstable numeric slot. The real danger is silent semantic drift before the function call. Terraform only checks list length and key type. It does not know whether prod was accidentally paired with the wrong CIDR block or whether owner received the log level value. On a submarine, a valve lineup can be technically complete and still be operationally wrong if one position was shifted during handoff. Zipmap has the same risk. The outcome is that a syntactically valid plan can still encode the wrong intent if positional data was assembled carelessly. In submarine operations, the checklist is not trusted just because every row is filled. We verify alignment between label, position, and expected state. With zipmap, treat list order the same way. A clean plan is not proof of a correct pairing. Zipmap is strongest when you first establish trustworthy ordering and then convert once. After the map exists, use key-based access for the rest of the configuration. This reduces index math, reduces accidental reordering bugs, and gives for each stable instance names. The outcome is code that expresses intent directly. First pair the data, then address it by meaning. Official docs define what zipmap returns, but the missing information gain is why it matters operationally. It is not just a map constructor. It is a boundary where positional data becomes identity data.